So lesson number 20. So today we're going to learn how to factor the difference of two squares, and we're going to keep doing quadratic trinomials, which we started last class, but they're going to be a little trickier because the leading coefficient's not going to be 1 anymore. All right, so I'm going to use a 2 by 2 box to factor 12x squared minus 75. But first, I'm going to factor out the GCF, right? So 12 and 75, do those two numbers have any factors that they share? 3 divides into both of those numbers. So I'm going to put a 3 here. Okay. And then what would I put in this first blank spot in the parentheses so that when I distribute the 3 to it, I get 12x squared? 4x squared. Yeah, because I didn't pull out an x. Why didn't I pull out an x? Why did I just write a plain old 3 and not a 3x? Because the 75 doesn't have an x, exactly. All right, so 3 times 4x squared gives me my 12x squared. What do I multiply 3 by to make 75? 25. Okay, so I factored out the GCF. Now I have to look at 4x squared minus 25. Now more details of this are written in your packet, but I'm going to just write it all from scratch here. I'm going to use the 2 by 2 box to do 4x squared minus 25. So first, I have to recognize that 4x squared minus 25 looks a little bit different than what we looked at last class. All of our things last class had an x squared term, an x term, and then a constant term. So I don't have an x term here, so I'm going to put one in, right? And it's going to become 4x squared plus something x minus 25. What could I put there so that this equation is actually true? What coefficient could I put on the x? Not 1. 1's a good guess, but 1, then there'd be an x here, and there actually are no x's. 0. Yeah, if I put a 0 there, now those two things are the same, and I've now written an x term.
But isn't multiplying that times 0 going to be 0?
Yes, multiplying by 0 is 0. That's the whole idea. I just wanted to make this look like the things we learned how to factor last class. And what we learned how to factor last class always had an x term. So I was like, all right, I'm just going to put one in with a 0. That way I can use the method that we learned last class. All right, so now I'm going to draw a 2 by 2 box. And remember, you always put the quadratic term, the first thing, in the upper left. So this is going to be 4x squared. And then you put the constant term, the thing that has no x's, in the lower right. And then you multiply 4x squared times negative 25. What do you get when you multiply those?
100x squared.
Negative 100x squared. Okay. So I've got a negative 100x squared here. And I want to list some factors, right? What are some things I could multiply together to make negative 100x squared? Negative 10x and positive 10x, right? That would multiply to make negative 100x squared. Negative 50 and 2x. Yeah, negative 50x and 2x. Yeah. 100 has a lot of factors. Negative 25 and 4. All right, that's enough because I know the one that's going to work is in there. Basically, you just start listing them until you find the one that works. So what am I looking for? I'm looking for these things, these factors I've listed, to add up to what? 0, the middle term. I'm looking to make them add up to 0. So which set does that? The first one, the 10 and the negative 10, those add up to 0. So you put those in your box. 10x, negative 10x, and it doesn't matter which one you put where. All right, then look at just the first row. Okay, and we're going to take out the GCF from just the first row. Do 4 and 10 have any common factors? 2. Okay. X squared and x, do they have any common factors? X. Okay, good. And then what do you have to multiply 2x by to make 4x squared? Another 2x. Yeah, so now we've got 2x and 2x. That gives us the 4x squared. What do you have to multiply 2x by to make 10x? 5. And okay, so now I have 3 of my 4 spots filled in. I just need this last one. And I know that when I multiply this 2x times whatever goes here, I get negative 10x. So what goes there? Negative 5. All right, so my final factorization, 2, there we go. My final factorization, that's a positive 5, so it's a plus, is going to be 2x squared plus 5 times 2x minus 5.
Which do 2x plus 5, 2x minus 5, not 2x cubed. Multiply that. End up with 4x cubed.
Oh. Yes, you're right. It's just 2x and 2x. Silly me. Yeah, 2x and 2x. 2x plus 5, 2x minus 5. That was just a 2x. When I factored out the GCF, I got 2x, and I knew a 2x had to go up here. 2x times 2x is 4x squared. Okay, question is, how do you do that without the box? Okay. So let's see, I had 4x squared minus 25. So is this how you're used to doing it? Okay, so a lot of algebra students call this the double bubble. It's kind of fun. Okay, so then you have to think of whatever goes here and here has to always multiply to 4x squared, right? And whatever goes here and here has to multiply to negative 25. Okay, and there's just going to be a lot of guess and check, right? So if I put 2x and 2x, then you multiply them together and you go, okay, yeah, that gives me 4x squared. Do you know FOIL, or do you just distribute? FOIL? Okay. So this is 4x squared, and then when you do the outer and the inner, terms, the multiplying, they have to add up to 0 because there's no x term. And then these guys have to multiply to 25. So give me some factors of 25. I could have 5 and 5. Are there any other integer factors of 25? Yeah, whole numbers. No. So I have to put a 5 here and a 5 here. That's my only choice. Those are the only 2 whole numbers. I could do 25 and 1, but it's unlikely that if I did 25 and 1 that I could get the inner and outer to add up to 0. So then you go, okay, that's 4x squared. I have 10x and 10x. So one has to be positive and one has to be negative to get them to go away, and then negative 25. Then you just have to guess and check, and when you do the outer and the inner of the FOIL, it has to add up to that middle number. Yeah. Okay, so some students also memorize the formula when there's no x term. When you have the difference of 2 squares, if it just looks like something squared minus something squared, it factors to, if you take the square root of the first thing and the square root of the second thing, a plus b times a minus b. So in our example, we started with 4x squared minus 25. If I just applied this formula, what's the square root of 4x squared? 2x, so that's my a. Square root of 25? 5. So this is 2x and 5, and then 1 is a plus and 1 is a minus. Then this formula doesn't help. Yeah, this only works if they're perfect squares. If it's not perfect squares, so that's the beauty of the box, is you can use it all the time and you don't have to memorize this formula. But if you find it handy, go ahead and memorize it. Okay, so sometimes you need to factor more than once. So we're going to do one more example where we have to do several different kinds of factoring in one problem. So first we look at 5x to the fourth minus 80, and you should always look for, always first look for a GCF, greatest common factor. Do 5 and 80 have any common factors? 5. We'll divide into both 5 and 80. So I take a 5 out, right? And then what do I multiply 5 by to make 5x to the fourth? X to the fourth, yep. What do I multiply 5 by to make 80? 16. Okay. So that's one piece of the factoring done. I pulled out the 5. Now, x to the fourth minus 16, bells should be going off about the 16. It's 4 squared. Yeah, it's a perfect square. Yeah. What about x to the fourth? It's x squared squared. Yeah, it's also a perfect square because the square root of x to the fourth is x squared. So I can use this formula, make the double bubble here. The square root of x to the fourth is x squared. The square root of 16 is 4, and one's plus and one's minus. And then any more alarm bells going off with the result?
Yeah,
the
both squares.
X squared minus 4, yeah. X squared plus 4 is impossible to factor. The sum of two squares, you just can't do anything to simplify that. But the difference of two squares, we can. Oh, I forgot my 5 from before. So this is 5, x squared plus 4. That just comes along for the ride. You got to copy it down. X squared minus 4. Running out of room. What's the square root of x squared? X. So x's go here. Square root of 4 is 2. So 2 goes there, and one's plus and one's minus. So
Yeah, we got x squared plus 4. Don't they both have to be either negative or positive?
the x squared plus 4 was just copied from the previous step, right? So like I had my 5 just got copied, it just came along. My x squared plus 4 just got copied, came along. And then the x squared minus 4, that got factored to x plus 2, x minus 2. Why can't you? Okay, let's try and do the box method on x squared plus 4. Okay, so you always put the x squared here, and you put the 4 here, right? And they multiply together to make 4x squared. And we start listing factors. What can you multiply together to make 4x squared? 2x, 2x, negative 2x, negative 2x, 4x, and 1x, negative 4x, and negative 1x. Does 4 have any other factors besides 2, 1, and 4? No. Okay. So I need to choose factors in order to do this process. I want to choose factors that add up to what for this problem? Because this was x squared plus 4 that we're working on, right? So the whole purpose of listing the factors is to choose the factors that add up to 0 in this case. Yeah, because there's no x, whatever the middle term is. In this case, there is no middle term, so we want them to add to 0. Are there any factors in this list that add up to 0? Nope. Can't do it. None add to 0. So x squared plus 4 just can't be rewritten as a product. Like think about the number 7. It's a prime number, right? So you can't rewrite it as a product, except itself times 1. I could do that with x squared plus 4 too. I could write x squared plus 4 times 1, right? But that's not really anything special. So some numbers are composite, like 12. You can rewrite it as lots of different but you could write it as 6 times 2 or 3 times 4. But 11, you can't. It doesn't have any factors. So x squared plus 4 is like that. It doesn't have any factors. All right. Any questions? Yeah, there's a formula called the quadratic formula. That might be what we're doing because we're multiplying a and c, right? When I wrote down this 4x squared, the a was 1 and the c was 4, so I am multiplying them together. Yeah, and you're looking for them to add up to the middle term. All right, so if you didn't finish the activity from last lesson, go back and finish that first, and then move on to the activity from this lesson.